Hey there, web enthusiasts! Welcome to the channel. Did you know that for every 100 milliseconds your page takes to load, you could be losing 1% of your revenue? Crazy, right? Stick around because we're about to share some simple tricks to speed up your web application. But first, why should you even care about your website speed? In our fast-paced online world, people want things quick. A slow website can turn visitors away, and that means less money for you. So, let's dive into some real-world examples. Imagine you walk into a store to buy a shirt. You ask the shopkeeper to show you some options, and he says, "Wait for 10 minutes, and then I'll show you the shirts." What would you do? Most likely, you leave and head to another shop, right? We're all a bit impatient, and we want things fast. The same principle applies to web applications. If your website is slow, users won't hesitate to close the page and move on to a faster alternative. Let's make sure that doesn't happen to your site. Now that we understand the importance of website performance, let's dive into the nitty-gritty of improving it. How do we measure performance of a web application? There are various tools out there. Lighthouse is one of the most popular one. You can find it for free in your Chrome browser. Lighthouse not only measures your web app's performance but also provides a list of suggestions to enhance it. If you're interested in a dedicated video on Lighthouse, drop a comment below. Now, when it comes to boosting performance, a great starting point is reducing resource size. A web page relies on various resources like HTML, CSS, JavaScript, images, and more. Shrinking the size of these resources can significantly enhance your web page's speed. In this video, our spotlight is on the size of JavaScript bundle. With the rise of single-page applications, sparse, JavaScript has become a crucial component. Sparse load a single HTML page and then fetch JavaScript files to dynamically render content. The catch? If JavaScript bundle is hefty, it'll take longer to load the page. So, let's tackle that issue without compromising functionality. I will walk you through 3 techniques to trim down the JavaScript bundle. 1. Minification and Uglification. 2. Tree shaking. 3. Code splitting and lazy loading. Minification. In a nutshell, minification is like giving your code a spring cleaning. It removes unnecessary characters from the source code without altering its functionality. Think comments, new lines, and white spaces, all things that make the code readable for humans but aren't essential for the browser to execute it. By stripping away these elements, we significantly cut down the size of our code. Uglification? Uglification transforms your code into an unreadable form by changing variable names, function names, and more, essentially hiding the original content. This process, also known as mangling, is irreversible. Once your code is uglified, there's no turning back. It's like putting your code through a secret identity transformation. This is particularly beneficial for production applications as it not only makes the code hard to understand, but also reduces its size. Now, let's see a quick demonstration using an online tool. On the right side of the tool, you can compare the original code with the minified version. You'll notice a 37% reduction in code size, not too shabby, right? Now, doing this manually might not be practical for large projects, but it's essential to grasp the process. Thankfully, there are tools like Webpack, Rollup, and others that can automate this minification and uglification process for you. These tools often come with plugins that seamlessly integrate into your workflow, ensuring your code stays lean and mean without you breaking a sweat. Next up, we have tree shaking. So, what exactly is tree shaking? Well, it's a technique that targets the dead weight in your JavaScript bundle, the unused code. This process eliminates functions, classes, and other bits of code that may be lurking in the shadows of your application but aren't actually contributing to its functionality. This technique becomes particularly handy for large applications with loads of functions and classes that may go untouched. To illustrate this, let me share an example. I created a simple e-commerce application with 2 pages, one for product listings and another for product details. For this project, I utilized 2 libraries, Lodash and MUI. Now, here's the catch, I only used one function from Lodash and a handful of components from MUI. But these libraries come with a ton of other functions and components that I didn't touch. Running the build command for application, you'll notice that the size of the JavaScript bundle is 109.1 KB. Now, let's see how we can optimize this bundle using tree shaking. The first step is updating import statements. Instead of loading from the root file of the library, we switch to loading from the absolute path. For instance, if we're fetching the map function from Lodash, instead of loading it from the root, we'll load it from the absolute path, Lodasher map. With this simple adjustment, the magic happens. The size of the JavaScript bundle drops from 109.1 KB to a more manageable 90.38 KB. That's a reduction of almost 20%, and we achieved this by just shaking off the unnecessary bits using tree shaking. Now, here's the cool part, you can check in your own applications if tree shaking is possible. If it is, you can swiftly update your import statements, reducing the size of your JavaScript bundle without compromising the functionality of your application. Finally, we have code splitting and lazy loading. So, what exactly is code splitting? It's the art of breaking down your JavaScript bundle into multiple smaller bundles. By doing this, we can load only the necessary JavaScript files for a specific page, reducing the initial load time of our application. Think of it as serving only what's needed when it's needed. Let's go back to our e-commerce application example. Right now, we only have 2 pages, but imagine a real-world scenario with pages like login, register, home, product list, product details, cart, checkout, and more. Loading all JavaScript files at once would bog down the page load time. The best place to implement code splitting and lazy loading is at the root level. By splitting the JavaScript bundle based on roots, we load only the necessary JavaScript files when the user navigates to a specific route. This not only enhances the user experience but also conserves network bandwidth. In React applications, achieving code splitting and lazy loading is a breeze. We can utilize React.lazy and suspense to seamlessly implement these optimizations. Running the build command will generate multiple JavaScript files, each corresponding to a specific route. Let me show you this in action. When I open the app in the browser, only the product list chunk file is loaded. As I navigate to the product details page, the corresponding chunk file is dynamically loaded, as you can see in the Network tab. And now, for a bonus tip, magic comments. You can use these comments to name the chunk file when importing a component. This special comment guides the compiler to name the chunk file based on the comment, making it incredibly useful for identifying specific chunks. That's it for this video. Stay tuned for our next video, where we'll explore different rendering techniques and find out which one suits your application best. If you've gained something new today, drop a like, hit subscribe, and ring that bell for more coding insights. If you have any questions, feel free to ask in the comments below. Until next time, happy coding!